everybody can hear me, I guess. Okay, yes. Thanks for being that I can be here and present this talk here. This is in collaboration with my colleague Volker Jacht, and actually most of what you will see here in this talk is based on his ideas, and so the whole architecture actually, how to include PETSc in our overall software development. However, he's currently on anniversary vacation with his wife, so he can't be here. So it's my honor to present this work. Okay, so let's start with what I think I've heard so far, how people use PETSc here. You have your application, you have PETSc, you try to connect it to solve some problems or sub-problems in your application. Sometimes maybe like Sarah told us this afternoon already, that you build your application and then you come to a point where you need something that PETSc can deliver for you, and then you incorporate it on the go. And unfortunately at GRS we don't live in that world. We have some more applications that interact with what Volker and I work on. And if you have this general configuration here, you can say, okay, it's your app, there are other apps as well, or you can say it's a large software with different modules, and each module has its own development team. So everything is, regarding code-wise, everything is pretty large, lots of lines of codes. And yeah, you have to take that actually into consideration when you do your development. And these guys, of course, come with some demands. They don't want you to change anything that's regarding their development. Especially, they don't want you to mess with the build process. There is some interaction with your application, but just because you introduce the new guy, PETSc, actually nothing should change for them in a way. And yeah, actually their build process as well as their development when they are coding. Furthermore, there are not just other developers with other modules or other applications, there are users as well, or could be users as well, which use some kind of UI to access the whole bunch of programs the company develops, and they come with some demands as well. Especially when you know PETSc is a new guy, then there was something before, and these people definitely don't want that the old things break. They still have to work. And what's always good, because these users are already so far away from PETSc, they don't actually care about PETSc. Yeah, it sounds very bad in this environment here, but they don't care. For them, it's just a black box. You put something in, something comes out, and hopefully it's faster or more reliable. So they want something like KISS principle. I don't know if this is something, I think it comes from game designing. This is keep it simple and stupid. So it's, yeah, we have to take that into consideration as well. So there are other guys. For example, we have some QA department which says, okay, if you want to introduce something, please, you have to stick to our rules. Then we have the deployment management, which says, okay, you see, we have a bunch of software and we put everything together and develop and deploy it to our customers or to our users. And I use here a German term, it's called Bringschuld. I use it because it's so small and concise. And actually in English, it's a legal term actually, but it's used in IT as well. And it means the obligation to comply with what is already there. Yeah, but it's a bit large for the bubble. Okay, then we have the legal department, something you should never forget. There could be some legal guy and say, it's totally fine and cool what you do, but you're not allowed to do it. And actually, when you do your work, start your work, and you want to introduce something new, this is one of the guys you have to talk at the very beginning. Before you put a lot of work in what you think is very nice, and maybe the others like it too, but this guy says no, it's not allowed. What is usually necessary, even if it's allowed, you need to provide licenses. You know it from, you download I don't know, something from Intel, MPI, or some runtimes, there's always some folder that says, okay, this is a third-party software we use, and yeah, this could be true for your company as well. Okay, where does this general framework come from? Oh, sorry, there's of course a boss ahead of the department which simply says, okay, make it work, yeah? You want this new guy, you want to bring it into play, this PETSc guy, it's your responsibility to make it work. Okay, so we find ourselves in an environment where we not only work with PETSc and have to take care of the actual things it should do for us, but there's an environment which comes with a lot of requirements as well. So there's some real application background for that. It's just not a product of our minds. And as you can see here, we have this configuration here on the lower side of the slide. This is our numerical toolkit. We abbreviate it with NUT, and this is what uses PETSc, and we provide a nice wrapper for PETSc that it's very easy for the other developers for the three applications you see down here to actually make use of these linear algebra routines. The overall background, application background, is transients and accidents in nuclear power plants to simulate them. It's usually much better than to do some field testing. And we have 3 programs here, which is the first one here is more concerned with the primary coolant circuit. CD stands for core degradation, so even melting processes can be simulated by it. Then we have this athlete, which takes care mostly of the secondary coolant circuit. So if there are any leaks in the pipes, these kinds of transients and accidents can be simulated by this. And then we have this COCOSYS. This is a containment code, so this is everything around these reactor vessels and the turbines and the pipes and so on. This altogether we call AC2 or AC squared. I usually say AC2 because it's easier. And there is some development history related to these. NUT is pretty young. This is like Volker and I started, I don't know, when was my first PETSc meeting? Somewhere in Vienna, I don't know, what was it, 2017, something like this? And that was the time when we started incorporating this PETSc. And all the other guys in this game are already 30 or 40 years old. Yeah? So you have to take that into consideration. Okay, just a quick overview how we end up with the linear algebra. So we have the conservation of mass, energy, momentum for liquid and vapor in more or less in these pipes or vessels. Then there comes some more or less usual finite volume approach, but it's one-dimensional, everything pretty easy if you do things one-dimensional. Then comes some, I'd always call it some engineering magic that we end up finally with some stiff initial value problems, but with the independence values are pressure, temperature of liquid and vapor, and some ratio value which tells you regarding the mass how much liquid and vapor you have in your control volumes. And all these control volumes are interconnected with mass flows. So this ends up in a system of ODEs which are stiff, so we need to solve some linear equations which involves the Jacobian of the right-hand side of the stiff system. Okay, we do the numerical integrations ourselves because these programs have some, I'd say, very specific requirements regarding the control, and we haven't touched that yet, but I think this will be something we do in the near future. Okay, so this is the background. We see there is some example where what I showed on the first slide actually exists. Now to actually see how to meet all these requirements from the different parties, we have to take a closer look at the software architecture which is used in our overall program AC2. So we have this numerical toolkit again. This has some static library involved in the executable, this libnut core, which does the actual talking to PETSc, and it's not just PETSc, we use mumps and meters as well to have some direct sparse solver available, just as some alternative. And everything is based currently on Intel MKL. For our earlier approaches, we use LAPAC and scale LAPAC from LetLib, but they changed with a version update. They changed some things in the CMake configuration with the Fortran name mangling, and this was not very fortunate. I think it comes later on a later slide, but we have to provide our software on Linux and Windows. Yeah, this is pretty important. It brings a lot of problems to say, okay, we want our software on Windows as well, or let's say a lot of challenges we had to overcome. And so the update of LAPAC and scale LAPAC wasn't very fortunate regarding Windows, so we changed to MKL. It was the next best we could use, and Intel is very good at providing things for both platforms. Okay, we can use the MPI mechanism in PETSc. There's no problem for NUT. As you may have seen already, this SLab process over there has no clue of MPI, so we have to keep it away from it so that the devs don't say to us, wow, what's happening here? Why do we have some dependency on MPI here? What's going on? I don't want it. Then this cogosys is naturally given on an MPI basis. This is just, they use it in a very original sense that they send messages between these different processes which do different things. It's not like they want to accelerate parallel computing. It's just sending a message, hey, do this for me, and I want this from there. Okay, how to incorporate this NUT and therefore PETSc? We use this plug-in mechanism. And this is pretty nice because this means I can load it during runtime or not. So I can keep things very separated from each other. This is something which the developers and of course the users like as well, because if I don't want it, I simply don't load it. I don't tick a box that I want to use NUT and therefore PETSc, and everything is like before. Okay, to make this actually available, we use some open source library, FDE, Fortran development extensions. As you might have seen already, we have this NUT fmods over there that we provide some interface that the codes, when they want to use NUT and therefore PETSc, that they know how to use it. And all these programs, the 30, 40-year-old programs, they're all written in Fortran. And to use this plug-in mechanism, we needed this Fortran development extensions, which is developed by one of our colleagues, and he made it publicly available under GitLab, and it's LGPL, so it's pretty easy to bring it into actually any program. NUT itself is written in C++. There's much easier, much more concise code than Fortran. And we use the C interface to PETSc, which is, I think, the natural, this is the natural interface. We started with a NUT version, which was written in Fortran, and and used the Fortran interface of PETSc, but I think it's less tested, and sometimes we got some problems there and said, okay, let's scrap it all, start anew, and do everything in C and C++. Okay. As you see here, we have multiple process groups, MPI related, and it's quite a challenge to start to initialize everything so that we know who is talking to whom and who is allowed to talk to whom, and how do the processes tell each other who they want to talk to. They don't always want to talk to everyone, so MPI conworld is not the way to go. And we use this little library MMA, MPI for multiple applications. This was written by Volker, the co-author of the talk, and this is also publicly available via GitLab, and it's a BSD2 license. Okay, this is a neat little library. I think I talked about it in Atlanta already. I presented it, and it helps a lot to keep a lot of the details, how everything is initiated MPI-wise from the user. So it's pretty nice to use that. Okay, how to actually get our hands on all of these things. So we have to provide the data in a good way. And as you can see in the leftmost column, we have native Git repositories for our own codes. This sounds quite natural. And the NAT repository also provides the code for the plugin and the fmods, just because it makes sense to have everything in one place. Because plugins and fmods could be used by many applications, it makes no sense to put them in the repository of these applications. Then you have to maintain them k times, and you only wanted to maintain one time. Then we have mirrors for all the PETSc related things. As you can see, we still use the mirrors of mums and meters from the Bitbucket place. If you change anything, please announce it in a good way. And the FDE and MMA, these auxiliary programs I just told you about, these are available as mirrors as well. On our object storage, which is based on MinIO, there we have the MKL into MKL offline installer, as well as for MPI and all our compilers. And by the way, we still use the classic compilers from Intel for Fortran, not the new one IFX, because there are still some problems, I'd say, which this compiler can't handle for us, so we still stick to the old one. And which I come later to, the Docker images, which we use for building and test environments. These are stored on our object storage as well, and we also build them ourselves. We have all the Docker configuration files stored on our GitLab server as well, so everything is locally available. This is pretty important for us so that we can easily do some versioning via Git and GitLab, and we have easy and reliable access. We don't have to rely on external sources. This is very good for the QA and for the deployment management, because the deployment management wants to know, okay, where do I get my data from? And this has to be done in a reliable way.
Do you mind a question?
Yes.
How do you deal with a new release of PETSc in this environment with the Q&A?
I think this is on my next slide.
Great.
More or less answered. Let's see. Oh yeah, making PETSc available, the PETSc Builder project. So we came to a decision that to not, okay, let's put it in a different way. So the most important thing is the first bullet point, which says no sequin, because we need things on Windows as well. And we haven't seen a way how to provide PETSc without installing Cygwin and doing the compiling over there, feeding Cygwin from outside with the compilers so that it knows what to use, and that in the end something is produced which can be used inside a window environment, MS Windows environment. So we don't want the other devs to include Cygwin into their overall development process. This is an absolute no-go. So what we decided for is we pre-build PETSc, and then we develop, then we deploy to the other developers an archive, a binary. So to answer the question, this is more or less a discussion between Volker and me. When do we want to update PETSc? And in this project here, where you see the pipeline for the PETSc builder, it's quite conveniently configured. When we say, okay, we want to try out a new version, then we insert a commit or a tag, and then we give it a try. So the overall configuration for this project, I can show it on my laptop as well. It's quite easy. And after we think things are fine and we can use it and it's stable and blah, 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 then we build a new archive and tell everybody else, you need to involve a new commit hash for NAT, and NAT is the gatekeeper for PETSc, and all the other guys have to do is, there's a new commit for NAT, you don't take care about the details. Okay. As you can see, this is approved by many of the other parties. The developers like that they don't have to do anything at all. There's just another binary that is now part of what they do during their configuration step. And what we do as well is we add some licensings. And since we have mirrors, we have our own branches with only 1 or 2 commits, where we sometimes fix some minor building things where you guys maybe said, oh, we haven't done it yet because it's not so important for us. Often it's mums. Mums is often a problem, so we have to do some minor fixing there so that building works. And we add some licenses so that, as I said, everything is locally available, and we need the licenses to meet the requirements of the legal department. So, yeah, and what's very important here, when you get to a company where many people develop code, there's usually a coding policy, because now there's a binary, and this binary, of course, is built with a certain type of MPI version in the background. But since you have a coding policy, the people actually have to, when they develop a software, they have to use a certain compiler and version and a certain version of MPI and so on. And we can use these constraints and say, okay, this is a virtue for us. We simply build PETSc with these coding policy in mind, and then everything should work smoothly because PETSc already sticks in this way to the coding policy. So it's no problem to have a binary. Okay, then we have here different stages. I don't think we need to go into much detail here. This is more or less what I already said. In this build step here, we install MKL because it's not in one of our Docker images pre-installed yet, because we're still in the phase where we say, okay, is it good? Does it work? And not everybody, the other guys don't need MKL in their Docker images yet, so we haven't installed it there. So what's pretty nice, we create the archive, and using information which is given by PETSc and by GitLab, this PETSc version name, this is something we derive from the Git repository of PETSc using git describe and add some, it's actually more or less git describe. And the CI project ID and pipeline ID and image tags, this is information which is given for free by GitLab. So we can use it and name our archive accordingly. And it's very neat for QA, because then you can always see, okay, the 467 here is the project ID, and the 43599 is the pipeline ID. So it's always easy to backtrack where do things come from. That's very important. And the next important thing is that after we build things, we know that we have an archive available, and we can download it from GitLab and play with it and see if everything works and everything is like we want it. And only if we think it's okay, then we press the play button there, and then things are delivered to the registry, to the package registry. I don't know if you are familiar with GitLab, but if you create a new project, you can have some package registry as well, and then we uploaded it to a specific project, to the related package registry, and then every other project can download it from there, or you can download it manually. So, how to, now we know how to get our hands on PETSc, but how to incorporate actually the things, the overall configuration, especially for the other developers, so that things look all smooth on the outside. And for that, we use a tool called CMake. And what you see here in the scroll, in the blue scroll, this is a paragraph from Professional CMake, a practical guide. It's the beginning of chapter 2 with some additional formatting. And it says more or less, okay, you can describe your configuration in a platform-independent way, and you can use CMake to create build tool project files which are platform-specific. So, and we make strong use of this. Volker did a lot of work in this department. To me, CMake is a language, it's pretty powerful, but to me it's not so easy to read. But it's some script language, and it's easy to use and easy to run if you have set up everything nicely. So it's very good for the other developers. But you have to put in some work to make things work. Okay, what's important to us, the build to project files, which are supported are Make and Visual Studio as well. Yeah, and that's important for us because most of our developers use Visual Studio, and then we can create the projects files in one easy go for them. Okay, how to actually make use of this CMake? This is just a quick rundown. You can see the CMI at Git and at subdirectory. At subdirectory is some common CMake command which says, okay, do something. There's some subdirectory which has its own configuration, edit, and we see what will happen in this subdirectory to actually configure this part correctly. And the CMI, this is down over here. This is some additional third-party program, but it's publicly available. It's written by Volker. And the standard CMake can add subdirectories which are already there. And with the CMI, we can also add Git repositories, and we can add archives. So if NUT should be built so that we use PETSc, then we add this archive as well, and then it's downloaded to a certain subdirectory, so it's easy to access. And if we don't want it, and then we only provide NUT to the degree that we can build these interface fmods for the other applications, then you simply go on with the build configuration for the other applications. So it's very easy for the devs of the other applications to use. So I think we can skip the ACTU deployment. As you can see, there are a lot of jobs and a lot of stages to be done. This is the most important part for this talk here. There's some build column, and there we have 2 jobs. And since NUT is built, this build NUT flag in CMake is set to 1, and therefore PETSc as a pre-built library is downloaded, and everything is smoothly incorporated in the overall deployment pipeline for our project AC2. So this is good for the developer, for the deployment manager. We have a special job for the docs, which includes the licenses. This is good for the legal department. We have some encapsulation idea, everything which is needed. The application data, runtimes, PETSc, and MPI exec. This is all put into one archive. So if a user wants to run it, just go to the folder and you can run it there. It doesn't matter how your system looks like. And we do some testing as well using our Docker images for that. We use clean Docker images so we can see, okay, is everything actually working? And there is some release job, and so the archives, if everything is fine, are stored in the releases subsection of the GitLab project, so it's easy to backtrack where everything comes from. Quick note about usability. Only the last blue background is important. As you may have thought so far, oh, PETSc has all these nice command line parameters, and you can still use them, but we don't want the usual user to use them, yeah, because we want to keep things transparent and to meet the requirement of the KISS. And but if you insert the dev flag, then you can use all the PETSc command line options if you want to, so no problem. Okay, and this is the last slide, summary. So we showed how to incorporate PETSc in a multi-applications environment. Our standard tools are GitLab, and its CI feature. We make heavy use of it. CMake is very important to us, and Docker makes everything convenient and reliable to test and to build. And here's a list of the additional programs we used. And everything is, to the likings of the others so far. I hope you like it too. And in any case, thanks for your attention.
Thank you very much, Tim. Any questions? We're getting to the end of the time, so we can take questions for Tim offline while we get our next speaker ready. Let's thank him again one more time.